So again, take these next few minutes and complete that warm-up. All right, let's check over each of these answers and see how we did. So again, a big part of looking at these problems is going back and looking at vocabulary that we talked about in Chapter 1 and a little bit in Chapter 2. So the first vocabulary word we are talking about is additive inverses. So an additive inverse is essentially the opposite of a term. An additive inverse is essentially the opposite of a term. So if you have 4, its additive inverse is -4. If you have -x, its additive inverse is x. And if you have 5x, its additive inverse is -5x. And the additive inverse of 8y is -8y. So today what we're focusing on is really the property of substitution. So what we are doing is substituting a whole function in for another function. So in this example here, you were told substitute 2y minus 1 in for x in each of those equations. So hopefully you were able to identify the x value, replace it with that 2y, and then upon replacing it, you were able to combine like terms, simplify, and get down to a value. So in this case, in number 1, the value was 1. You could find the x value by plugging y back in. So the x value would be 2 times 1, which is 2, minus 1. So the x value would be 1. So the y value is 1, and the x value is 1. And we got all of that by using something called substitution. Where again, you can tell I took the box, I substituted it with this box, and I combined like terms. You were supposed to do the same thing in warm-up number 6. Everywhere you had an x, you were supposed to replace it with 2y minus 1. Replacing x with 2y minus 1 allowed you to distribute, combine like terms, and simplify down to a final answer of -2. Okay? And then for the last example, same idea. Everywhere you had an x, you are going to substitute in that y. Okay? So what I want to do today is a similar method, but we are going to have to decide what variable ourselves to solve for, and then we're going to substitute it in, and then we need to solve the system. So to solve the system, you need to actually find a value for x and a value for y. So we're going to solve our system, but we need to find an x and a y value that make both equations true. So after we find one variable, we have to go back and find the other variable. In number 1, we're looking at each of those terms, and we're looking at the coefficient of the terms. And when I look at this, I notice that the x value in number 1 has a coefficient of 1. So I'm going to choose to solve for x in equation 1. So I want to solve for x in equation 1. Let's zoom in on that. All right, so we're going to solve equation 1 for x. So by doing that, we get that x equals 12 minus 3y. X equals 12 minus 3y. And what we're going to do is just like the warm-up, we're going to replace the x in the other equation with the x we just solved for, or it's 12 minus 3y. So we get negative 2, but now instead of writing x, I'm going to write 12 minus 3y. And what that does is it turns the second equation into all y's. So I can now distribute, combine like terms, and solve for y. All things we've done in chapter 1 and 2. So distribute. A negative times a negative is a positive. Combine like terms. So we're going to group 6y and 4y to get 10y. I'm going to add 24 so it moves to the other side. So 9 and 24 gives me 33. And then I'm going to solve for y by dividing both sides by 10. And I get y equals 33 over 10, or 3.3. And then what I'm going to do is take that y and plug it back in here. I can plug it back in there. I can plug it back in here. So I can plug y in for y in any of those equations to solve for x. So 9.9 subtracted from 12 is 8.1. Or 3.1. Okay. Let's look at example number 2. So we have 2x minus 3y equals 6. And we have x plus y equals negative 12. So once again, we can choose to solve for any of those values for our x or y from the second equation. So you could solve for x or y in equation 2. I'm going to, just to be different, solve for y. This time we're going to plug that value of y into the top equation for y. So we have 2x minus 3, and now my y value is negative 12 minus x equals 6. So I'm going to distribute. Negative times a negative is a positive. Combine like terms, so I'm going to subtract 36 from both sides. 2 and 3 add together to give me 5. 6 minus 36 is negative 30. Divide both sides by 5, and I get x equals negative 6. I'm not done. I need to know y. So maybe I plug x into the solved for y. So I get negative y minus a minus 6. So that turns to a positive. Negative y plus 6 gives me a negative 6 for y as well. And that should make sense because negative 6 plus negative 6 is negative 12. Number 3. Same idea. This time we're also going to solve for y because it's the only variable that does not have a number on it. So you always want to pick the variable without a number. So we get 3x equals y. Remember that multiplication and addition are commutative, as are properties symmetric and reflexive. So 3x equals y is the same as y equals 3x. The order doesn't matter. So I'm going to replace my y with 3x. Then I'm going to solve for x. And we get x equals 2. But we're not done. We got to plug 2 back in. And we get y equals 6. These are problems where if you're not used to boxing in your answers, you might want to. Because when you're checking your work, or we're checking your work in class, and you have all that work happening, it's really nice to just be able to find your answer, to check it before you move forward. So everybody good with examples 1, 2, and 3. We understand substitution method. Hopefully it's coming back to you because this is definitely something you should have learned in Algebra 1. Okay, so obviously, it is a concept you learned in Algebra 1. But in Algebra 2, we are focusing a lot more on the word problems, getting ready to, prepare for those SATs you might be taking. Some of you in here, I think, are actually taking the keystones, so there's word problems on the keystones. And again, it gets you thinking, how does math apply in real life? So maybe one day you want to own a pizza shop. So you might have to come up with deals that matter for the pizza shop. And this is one way you could use this concept to help you come up with deals for your pizza shop. So it says a soda and 2 slices of pizza cost $10.25. So we're talking about soda and we're talking about pizza. So I'm going to pick 2 variables. I'm going to pick S for soda and P for pizza. So again, that's a concept I sometimes put on your tests, and I say, define the variables. And that's what we're doing here. All you're doing is telling me, what does the variable represent? So we have a soda, so that's like 1S, plus 2 slices of pizza, so that's 2S, wow, 2P equals 10.25. 1 soda plus 4 pizzas equals $18.75. So hopefully you recognize that these represent a system of equations, just like we had in the previous 3 examples. So it's called a system of equations. So what we're going to do is solve for the variable with a coefficient of 1. So in this case, I'm going to solve for s and say that it equals 10.25 minus 2p. And then I'm going to replace s in the second equation with my solved for s in this equation. So it's kind of like when I'm teaching you, I'm here, I'm in the classroom. Some days I miss. A substitute comes in. They replace me. So that 10.25 minus 2p is kind of like my sub. That's like Mrs. Ward coming in. She's going to teach you for a little bit, and then I'm going to come back. So substitution in math is kind of like a substitute teacher at school. So you get 1, but now it's times 10.25 minus 2p plus 4p equals 18.75. And then what we need to do is solve for p. So combining like terms, 4p minus 2p is 2p. And then 10.25 is going to get subtracted to the other side. So 18 minus 10 is 8. 0.75 minus 0.25 is 0.5. Divide both sides by 2. And we get that a slice of pizza is $4.25. But I need to know how much a soda is. So we're going to plug that p-value back in. So you get 10.25 minus 2 times 4.25, which is like 10.25 minus 8.5. So 10 minus 8 is 2, but then you're taking away that 50 cents from 25. So one soda costs $1.75. I'm really hoping it's a 2-liter and not a can. Those better be some big slices of pizza. Okay? One more word problem. So back in the day, probably pre all of your days, we used to actually go to stores. Hey, guys, give me CDs at the local store for $15.49 each. You can buy them online for $13.99. However, pre-Amazon Prime days, if you bought something online, it costs money to ship it. So for one order of CDs, it costs $6. $6 is a flat shipping rate. It's not per CD. So it says find the number of CDs you can buy at the same amount, whether you bought them online or in the store. Because at some point it's cheaper for in-store and at some point it's cheaper online. What we want to know is when will the cost be the same? So we're going to call our cost our C value. And then we'll say X is the number of CDs. So the cost to buy them in store would be 15.49X. The cost to buy it online would be 13.99X plus that $6 shipping fee. And we want to know when will the cost be the same. So what we're going to do for this problem is set those two equations equal to each other. So you'll subtract oops, I missed my 9. 1399x from 1549x. And then we're going to have to divide that. So we get $1.47x equals 6. So we divide by $1.47. Actually, sorry, I'm pretty sure I hit it. Should be $1.50. I typed in 15.46, not 49. So 6 divided by 1.5 is 4. So if I buy 4 CDs, it would cost me the same in-store as it would online if I were to buy 4 CDs. I don't buy CDs. I just listen to Apple Music. On my Android, because I don't like Apple products. Alright guys, your homework is that very next page at 10 a.m. So what we do for homework today, what you're doing in class tomorrow, everything is due at 10 a.m. on Monday. When we all come back and we do lesson 3-2, day 2, which is elimination. So again, we're going to work on substitution today and tomorrow, and then we'll do elimination on Monday.